Okay, we're going to continue our topic of monomials and polynomials, and we're going to focus on adding and subtracting polynomials and then multiplying with some larger polynomials. Okay, so first of all, when we're adding polynomials, we want to make sure that we're going to add the like terms. So how do we tell if terms are like terms? Like terms have the same variable or variables, and they have to have exactly the same exponents. So let's take a look at an example. We want to add 9a squared plus 4a minus 3, that polynomial, to the polynomial 2a squared minus 6. And the first thing I'm going to do is rewrite this with the terms that are like next to each other. So for example, 9a squared and 2a squared has the same variable a, same exponent, which is 2. So I'll write those next to each other. Then I notice that 3 and 6 are both constants, so I'm going to be able to add those two together. 4a is the only a term, so that guy is going to be by itself. So basically we have 9a squared plus 2a squared plus 4a minus 3 minus 6. If we add 9a plus 2a squared, 9a squared plus 2a squared, we get 11a squared plus 4a, and then negative 3 minus 6 is negative 9. Let's take a look at this other example. Here we have 5 times 3x minus 4 plus 6x times 8x plus 4. So we have to use the distributive property first. So we'll multiply 5 times 3x to get 15x, and then 5 times negative 4 to get negative 20. Then we're going to add that polynomial to 6x times 8x, which is 48x squared. 6x times 4 is 24x. So let's identify our like terms. 48x squared is the only x squared term. Then we're going to have 15x and 24x. So we will be able to add those two together. And then we have only one constant, negative 20. So let's simplify this. We're going to have 48x squared, it's the only x squared term. 15 plus 24 is 39x, and then minus 20. Now you're done here. Notice how these have different exponents. You can't combine those two terms together. So right here we're finished simplifying our polynomial expression and adding those two polynomials together. So the same thing is true when we're subtracting polynomials. The only thing that you have to be careful of when subtracting polynomials is to add the opposite of each term in the polynomial that's being subtracted. And then this is another way of just saying distribute the negative, and that's the piece that people often forget when they're subtracting polynomials. They'll subtract the first term, but they'll forget that they really have to subtract all the other terms as well. So let's take a look at this example. We have 7x cubed minus 5x squared plus 9 minus the entire polynomial x squared minus 8x plus 4. So if I distribute that negative, or if I subtract each of these terms, it becomes 7x cubed minus 5x squared plus 9, the same first polynomial, minus x squared plus 8x, because we were subtracting negative 8x, so that becomes plus 8x, and then minus a positive 4 will be minus 4. So now let's collect our like terms. 7x cubed is the only x cubed term. Then we have minus 5x squared and minus x squared. Then we have plus 8x is the only x term, and then plus 9 minus 4. So we can add negative 5x squared and negative x squared, and we can add our constants as well to get 7x cubed minus 6x squared plus 8x plus 5. One more example here. Let's subtract these polynomials. Notice that this one has a negative on the outside of the polynomial first, so I must take care of that right off the bat. So we'll have negative 15k to the fourth plus, because we have minus a negative, 5k squared, and then minus a positive 1. And then we're going to subtract from that 10 times the rest of this polynomial. So think about this as negative 10 times k squared, negative 10 times negative f, so that would be plus 10f, and then negative 10 times positive 1, so minus 10. So we kind of had to run out of room there, but let's clean this up and see if we have any like terms. When we have 5k squared and negative 10k squared, we have negative 1 and negative 10. Those are like terms, so if we rewrite this, we have negative 15k to the fourth, 5k squared minus 10k squared is going to be minus 5k squared. And then we have minus 1 minus 10, so that would be minus 11. And then we have this plus 10f. So we have two different variables in this case, and we can't combine any of those together, because remember, like terms have to have the same variables and same exponents. Okay, let's talk quickly about multiplying. When we multiply polynomials, we want to multiply the coefficients and add the exponents of like variables when multiplying. So one example of multiplying two binomials, a lot of times we think of FOIL, which is to multiply the first terms together, the outer terms together, then the inner terms together, and then the last terms together. So let's take a look at an example. If we have c squared plus 6 times 3c minus 8, my first term in each of those two polynomials is c squared and 3c. So if I multiply those together, multiply the coefficients, so that's 1c, so 3 times 1 is 3, and then add the exponents, 2 plus 1 is 3, so we have 3c to the third. My outers would be c squared and negative 8, so that would be minus 8c squared when I multiply it together. My inners would be 6 and 3c, so if I multiply those together, 6 times 3 is 18c, and then my last 6 and negative 8 is minus 48. So that's a real quick, easy way to remember how to multiply every term in the first polynomial times every term in the second polynomial. Here's another method for helping you to organize your multiplication when you have larger polynomials that you're multiplying together, and I call it the box method. Notice here my first polynomial only has 2 terms, 2x squared plus 10, but my second polynomial has 3 terms. And I really like this box method because it helps make sure that I multiply every single term in the first one by every single term in the second one. You're not going to forget anything when you use this method. So what I do is I take one polynomial and I write it across the top, and I take the other polynomial's terms and I write them vertically. And we're just going to multiply, just like we do in our times tables, all the terms together. So for example, 2x squared times 2x squared is 2x to the fourth. 2x squared times 5x is going to be a positive 10x cubed. 2x squared times negative 4 is going to be negative 8x squared. And then we do it with a 10. So 10 times x squared is positive 10x squared. 10 times 5x is 50x, and 10 times negative 4 is negative 40. Now all we have to do is look and see if we have any like terms. So I notice I have an x squared term and an x squared term there, so I'm going to combine those. So my final answer will be 2x to the fourth plus 10x cubed. Negative 8x squared plus 10x squared is 2x squared plus 50x minus 40, and we're done. Okay, now we got to talk about rational expressions. So an expression that can be written as a ratio of two polynomials is a rational expression. So let's just take a look at an example. Notice how my numerator is a polynomial, x plus 3. My denominator is also a polynomial, x squared minus 5x plus 3. So we're looking at the ratio of those two polynomials, so that's what makes it a rational expression. Ratio here. If I want to add two rational expressions, just like adding fractions, they must have the same denominator, right? We can't add 1/2 plus 1/3. We have to have the same denominator in order to add fractions. So here if we take a look at this example, 4x plus 3 over 2x plus 2x squared plus 5 over 2x, they already have the same denominator, so I'm able to add them together. Just like fractions, if you had 1/2 plus 3/2, all we do is add the numerators. That's 1 plus 3 over 2, that's 4/2. We're going to do the same thing with rational expressions. So all I'm going to do is add the numerators. So this becomes 4x plus 3 plus 2x squared plus 5 over 2x. Combine my like terms, we have 2x squared, 4x and 5x is 9x, plus 3 all over 2x. Notice that that denominator stays the same. Let's look at one more example here. Let's add these two together. Well, in the first one, notice I have some multiplication that I have to take care of first. So we have to distribute that 3h. So we have 3h squared, 3h times 2 is 6h. Then we're going to add the second numerator, 4h squared plus 1, and then my denominator, 5h plus 1, stays the same. Collecting our like terms, we have 3h squared and 4h squared is 7h squared, plus 6h plus 1, all over 5h plus 1, and we're done. Our denominator stays exactly the same. So the same thing is true if we want to subtract rational expressions, but remember, just like with subtracting polynomials, we have to subtract the entire second expression. That means subtract the entire numerator of the second expression. So if we had 6x squared plus 10x over 2x minus 1 minus x squared minus 3g minus 2 over 2x minus 2x minus 1. Combining those together into a single fraction, 6x squared plus 10x, minus quantity x squared minus 3g minus 2. That's going to become 6x squared plus 10x minus x squared minus a negative 3g makes that plus 3g minus a negative 2 makes that plus 2 all over 2x minus 1. And let's see, we've got like terms here and here, so we can collect those. 6x squared minus x squared is 5x squared plus 10x plus 3g plus 2 all over 2x minus 1. All right, one last thing to talk about, and that is multiplying our rational expressions. This is different than adding and subtracting, where we had to have the same denominator. When we're multiplying, we don't have to have the same denominator. Just like with fractions, if I wanted to multiply 1/2 times 2/5, we don't have to have the same denominator. We multiply across the top, we multiply across the bottom. We're going to do the same thing with rational expressions. So if I want to multiply 5x plus 1 over 9x times 9x minus 6 over 2x squared, we're going to multiply 5x plus 1 times 9x minus 6, and then we're going to multiply 9x times 2x squared. So in the numerator here, I have to use our FOIL method, first outers, inners, last. So 5x times 9x is 45x squared. 5x times negative 6 is negative 30x. Inners, 1 times 9x is plus 9x. And then my lasts, 1 times negative 6 is minus 6. Then on the bottom, multiply the coefficients. 9 times 2 is 18. Add the exponents of the variable, so x cubed. And all we have to do now is collect the like terms in the numerator and simplify. So we have 45x squared minus negative 30 plus 9 is going to be negative 21x minus 6 over 18x to the third. Okay? And that's a simplified form of our polynomial there. And we're done with adding, subtracting, multiplying all of our polynomials, so we've got some good practice problems for you to do.